Hi guys, and welcome back. Let's go ahead and take a look at the documentation for how to install Kubeadm, and then we'll spin up an Amazon Web Services EC2 instance or Elastic Compute Cloud, which is basically just a virtual machine running Ubuntu Linux, and then we'll install Kubeadm on that Linux virtual machine in order to give us the ability to then initialize a new Kubernetes cluster. So in order to take a look at the documentation, we're going to head over to the Kubernetes.io website under docs, and they've got some really excellent documentation here that talks about how to bootstrap a cluster with Kubeadm. And then that's broken down into a bunch of different subtopics, such as how to install Kubeadm itself, how to troubleshoot any problems that you might come across with Kubeadm, and then of course how to create a cluster once you've got Kubeadm itself installed. How do I initialize a Kubernetes cluster and things like that. So let's head up, for starters, up to installing Kubeadm here and just kind of explore what we need. So for starters, we're going to need a compatible Linux host. Now, I often prefer to use Ubuntu Linux. However, there are plenty of other supported distributions of Linux out there that you could use as well. You could use SUSE Linux. In fact, SUSE acquired Rancher back in late 2020, I believe, and so they're definitely a good supporter of the Kubernetes project. You could also use just Debian Linux as well, or Red Hat Linux, which is a very popular distribution. So there's a bunch of different ones out there. I'm going to be using Ubuntu, which is actually based on Debian Linux. So that is definitely compatible. You will want to make sure that you have a couple of gigs of RAM available on each of your virtual machines as well. And this is important for especially the master nodes in your Kubernetes cluster, because you're going to want to make sure that the master nodes have enough space to run all of the different components, like the Kubernetes controller manager, the Kubernetes scheduler, as well as the API server that kubectl communicates with in order to administer your Kubernetes cluster. And if you don't have enough RAM to run all of those different components, then you may run into things like system crashes. You might run into just odd behavior from your Kubernetes cluster, and you can avoid that by ensuring that your master nodes have plenty of RAM. Now, as far as the worker nodes go, any worker nodes that you join to your cluster, you're going to want to make sure have enough RAM as well, because those worker nodes are the nodes in your cluster that are actually going to be running your different pods and containers inside of those pod specs. And so if you don't have enough RAM to run your different application components, like maybe you're running database servers like MySQL inside of containers, maybe you're running web servers, maybe you're running some middleware servers in there. If you don't have enough RAM to run your containers, then you're not going to be able to reliably run your application, as well as scale that application up when you actually need it. You also want to make sure you have enough CPU capacity as well, just so that your application components aren't fighting for CPU utilization. If you're running very CPU heavy processes, maybe you're building a website like YouTube, for example, where they're doing very heavy video processing, which is very CPU intensive work. If you are building a service like that, then your focus on having enough CPU and memory capacity, for that matter, is going to be essential. Also, you're going to want to make sure that you have network connectivity between the machines in the cluster. So this is really important, especially if you are dealing with things like multi-cloud scenarios, where maybe you've got some virtual machines running in Microsoft Azure, maybe you've got some virtual machines running in Amazon Web Services and other cloud vendors. In order to ensure that your cluster is functioning properly, you're going to want to make sure that you have routing between your different networks in different cloud vendors, or if you're doing something even just as simple as multi-region setups in something like Amazon VPC, where you've got two different VPCs that exist in different regions, then you want to make sure that you have routing set up between those VPCs so that your worker nodes can communicate with the master nodes, and so that the master nodes themselves can communicate with each other on TCP 643. And of course, your load balancers and ingress controllers and all of your pods are going to need to make sure that they have network connectivity as well. Also, this is kind of something I would take for granted, I should say, but oftentimes you might not be thinking about it, and you do want to make sure that you have a unique host name and MAC address for all of the nodes in your cluster, just to ensure that all of those nodes are uniquely identified within the cluster itself. Also, disabling swap is very important in order for the kubelet to work properly. And the kubelet is basically the component of software that you use as part of a Kubernetes cluster in order to register all of the nodes in your cluster with the Kubernetes master nodes. So that ensures that your worker nodes are going to be able to communicate with the API server and receive any instructions from the scheduler through the API server that they need to process, like starting up pods or deleting pods or creating services, that kind of thing. All right, so let's go ahead and start by spinning up a virtual machine, and then we're going to go ahead and basically just verify that we meet all of the dependencies in order to install Kubeadm and get our cluster up and running. So I'm going to head over to the AWS Management Console here. And what we're going to do for starters is just provision a new virtual private cloud. And this is basically the network environment that's going to host our cluster and allow all of our nodes to communicate with each other. Of course, we're going to start simple. We're just going to have a single node for starters. But if you did have additional nodes, you of course want to deploy them into the same VPC. Or if you're doing a more complex network setup, then you'd want to make sure that you have that routing all set up ahead of time. Now on the Amazon VPC dashboard here, you can just go to the Launch VPC wizard, and you can provision a VPC with both public and private subnets. And so we're going to go ahead and do that for now. And then you want to make sure that you just choose a private CIDR block for your cluster. I'll do something kind of random like 10.77/16. And then I'll call this K8S just so I can find this VPC later on. And then for our public subnets CIDR block, we're going to do something like 10.77.10/24. And then we'll do for our private subnet, we'll do 10.77.100 or maybe 110.0/24. So those are just a couple of different CIDR blocks for public and private. And we're also going to need to make sure that we allocate an elastic IP for our NAT gateway. So I'm going to head back to services and go over to VPC, and we'll head down to elastic IPs. Actually, I think that's over in EC2. So let's go over to, oh, here it is, elastic IPs. Some of those things only appear in the EC2 console, but let's go to allocate elastic IP. We'll just do our region here and do allocate, and then I'll just go ahead and give it a name like K8S. And let's come back here to our VPC console, and now we should be able to choose that elastic IP, and we'll go ahead and hit create VPC. So we'll give that a second to create, and then once our VPC has been created, we'll go ahead and spin up a virtual machine over in EC2 that is going to be a member of this VPC. All right, so our VPC has been created here, so we'll go ahead and head over to the EC2 console here, and we'll create a new virtual machine with Ubuntu Linux. So I'm going to go to launch instances here, and then I'll find Ubuntu 20.04 focal fossa right here. So I'm going to use that image. And then we're going to choose just a relatively small EC2 instance type. Of course, we want to make sure it's got enough vCPU and RAM. So I'm going to choose a T3 medium here because that has 2 virtual CPUs and 4 gigs of RAM. And then on our instance details here, I'm going to go ahead and choose my VPC. So let's choose our K8S VPC, choose our public subnet because we want to remotely log into that virtual machine with SSH, and then we'll enable auto-assign public IP so that we can remotely access that virtual machine. All right, let's go ahead and head to the storage screen next. And for storage, I'm going to make sure that my master nodes have, let's say, 30 gigabytes of storage. And then we'll go ahead and do review and launch, and then we'll hit launch, and I'm going to go ahead and create a new key pair here, and I'll just call this K8S cluster. Hit download key pair to download the private key for the cluster, and then we'll go ahead and hit launch instance. All right, so while that's launching, we need to make sure that we have access to log into this EC2 instance. So I'm going to head back over to EC2 here, and we're going to find the virtual machine that we just spun up, which is this T3 medium right here. And then I'm going to go over to security and find the security group. And we need to make sure that we have inbound SSH access. And it looks like the automatically generated security group already has a rule that allows inbound access from anywhere online to TCP port 22. So we'll be able to log into this virtual machine here in just a second. So let me call this K8s master, just to give it a friendly name in our console here. And now to log into it, I'll head over to the Details tab and find the public IPv4 address, and just click on this button to copy it to my clipboard. And then I'm going to go ahead and fire up a new terminal. And we're going to go ahead and just run SSH, and then we'll do Ubuntu at IP address. And then I also need to specify my private key, or my what's known as the identity file. So I'll do -I, and then go into my download folder, and then look for the K8s cluster key, and we'll go ahead and run that, and we'll confirm our host key, hit yes, and now we have our virtual machine here. So this is the virtual machine that we just spun up. So I'm going to go ahead and do a standard sudo apt update and sudo apt upgrade, just to make sure that all of our base operating system packages are up to date. And then we'll go ahead and disable swap as one of the first steps that we need to do. Awesome. Now that our packages are up to date, let's go ahead and check to make sure that swap is disabled. So I'll do sudo vim etc fs tab, and it looks like there is no swap actually configured on this focal fossa image that AWS provides, but you do just want to make sure that in fs tab that you don't have a swap partition there. Also, if I exit out of vim and I do a cat/proc/swap-s, then that will show you any swap partitions that are configured on your system here, and you can see that I have empty output. I'm also going to go ahead and change the host name of my node here. So by default, the Amazon Web Services platform assigns this IP address as its name, but I'm just going to go ahead and do sudo vim etc/hostname, and we'll go ahead and just delete that line with a dd command, and then I'll do insert, I for insert, and then we'll go ahead and call it K8s master 01. All right, now that I've renamed our node, let's go ahead and do a sudo reboot, and we'll let our system reboot, and we should have it named something else. So now that we've got this node up and running, we can go ahead and proceed with installing Kubeadm. I hope this has been informative for you, and I'd like to thank you for viewing.